There is a city in southern Italy that should not exist, not as we know it, not as we can walk through it today. It should have been lost forever, dissolved into legend, reduced to the kind of story that historians debate and poets romanticize, but no one can truly verify. And yet Pompeii is still there. You can walk its stone streets. You can stand in its bakeries, still stocked with the molds for bread. You can read the graffiti scratched into the walls by ordinary Romans going about their ordinary lives. You can look into the frozen faces of people who died nearly 2,000 years ago and feel with an almost unbearable intimacy that they were just like us. Pompeii was a prosperous Roman city situated at the foot of Mount Vesuvius, overlooking the Bay of Naples on the southwestern coast of Italy. At the time of its destruction, and the city was home to an estimated 20,000 people: merchants, slaves, politicians, soldiers, artisans, priests, and gladiators. It was alive with commerce, culture, and the messy business of human existence. Then in 79 AD, everything stopped. For centuries, what happened to Pompeii was understood only in the broadest strokes. A volcano erupted, ash fell, people died. A city was buried. The details, the precise sequence of events, the true causes of death, the identities of the victims frozen in time, remained locked inside the layers of volcanic deposit that covered the city to a depth of several meters. But science does not rest. And in recent years, using tools that would have seemed like magic to the people who died there, researchers have finally begun to peel back those layers. Not just the physical ones, but the layers of assumption, misidentification, and myth that had accumulated over the centuries just as surely as the ash itself. What they found changed everything. To understand how Pompeii's mystery was locked away for so long, you have to understand how little information survived in the first place. The eruption of Mount Vesuvius in 79 AD left behind almost no written records from survivors. The city was not just damaged, it was sealed. Those who escaped took what they could carry and did not return. Those who did not escape left no words behind. What the world knew of that day came almost entirely from a single source: the letters of a Roman statesman and lawyer named Gaius Caecilius Secundus, better known to history as Pliny the Younger. Pliny was 17 years old when Vesuvius erupted. He was staying in the naval town of Misenum, approximately 29 kilometers from the volcano across the Bay of Naples. He did not go to Pompeii that day. His uncle, Pliny the Elder, a celebrated naturalist who commanded the Roman fleet, sailed toward the eruption and never returned. The younger Pliny watched from safety, and decades later, around 107 or 108 AD, he wrote 2 letters to the historian Tacitus describing what he had witnessed and what he had been told by survivors of his uncle's expedition. Those 2 letters are the only surviving eyewitness account of the eruption. They describe an enormous cloud rising from the mountain in the shape of a pine tree, the rain of pumice and ash, the darkening of the sky, the earthquakes that shook the ground. They are vivid, detailed, and scientifically remarkable for their time. And they are our primary anchor to the historical reality of that day. But they also generated a debate that lasted for nearly 2,000 years. In his letter, Pliny gives a date for the eruption. In the most widely circulated and accepted translation, that date corresponds to August 24th, 79 AD. For centuries, this was taken as settled fact. The eruption of Vesuvius happened on August 24th. The case was closed, except it was not. As scholars examined Pompeii more closely, and as they dug up the ruins and analyzed the organic materials preserved within them, a troubling body of evidence accumulated. Archaeologists found the remains of pomegranates, figs, chestnuts, and walnuts in the ruins. These are autumn fruits. They would not be ready for harvest in August in the heat of southern Italy. They found victims wearing thick woolen cloaks, clothing that made no sense for a summer day in the Mediterranean. They found braziers that had been moved indoors, suggesting people were already preparing for cooler weather. In 2018, an extraordinary discovery seemed to tip the scales. During excavations at the House of the Garden in Pompeii, archaeologists found a charcoal inscription on a wall. The inscription contained the date 16 K9. In Roman calendar notation, the 16th day before the kalends of November, which corresponds to October 17th. If a construction worker had scrawled that date on a wall, and the eruption destroyed the city sometime after, then Vesuvius could not have erupted in August. The city was still standing in October. For a time, and this inscription became the most powerful piece of evidence for a revised timeline. Researchers announced with considerable confidence that Pompeii had died in autumn, not summer. But then science stepped in again and complicated things further. The director of the Pompeii Archaeological Park, Gabriel Zuchtriegel, and his team conducted a careful experimental study. They wanted to know how long a charcoal inscription could actually survive before becoming illegible. On October 12, 2023, they left their own charcoal inscription on the same type of wall that the ancient graffito had been found on. 10 months later, on August 24, 2024, the text was still perfectly clear and fresh-looking. In other words, an inscription made in October of one year could still be readable in August of the following year. The charcoal graffito dated to October 17th could have been written in October of 78 AD, 10 months before the eruption of August 79 AD. Simultaneously, scholars revisiting the manuscript tradition of Pliny's letters discovered that the confusion about the date had a more mundane origin. The original copies of Pliny's letters do not survive. What we have are medieval manuscript copies, and those copies diverge. Some suggest August 24th. Some suggest dates in October or November. Historian Peter Voss analyzed the manuscript tradition rigorously and concluded that all dates other than August 24th are, in his assessment, inventions without grounding in the manuscript evidence itself. As of today, the Pompeii Archaeological Park states that August 24th cannot be ruled out, but neither can it be definitively confirmed. The debate is not closed. It is, in fact, a perfect illustration of how science works. Evidence accumulates, assumptions are challenged, and certainty gives way to careful, qualified understanding. What the date debate revealed, above all, was that the story of Pompeii's destruction was far more complicated than anyone had admitted. To understand what killed the people of Pompeii, you need to understand what Vesuvius actually did, and in what sequence it did it. The eruption of 79 AD was not a single dramatic explosion. It was a sustained, multi-phase catastrophe that unfolded over approximately 2 days and produced a range of distinct and increasingly lethal phenomena. In the early afternoon of the first day, Vesuvius began its attack with a Plinian eruption column, a massive jet of superheated gas, ash, and volcanic rock that shot between 15 and 30 kilometers into the stratosphere. For 18 to 20 hours, this column rained pumice and ash down onto Pompeii and the surrounding region, accumulating deposits up to nearly 3 meters deep in some areas. Roofs collapsed under the weight. Streets became obstacle courses of stone and debris. The sky turned black in the middle of the day. People began to flee. Archaeologists estimate that somewhere between 10,000 and 12,000 people, the majority of Pompeii's population, managed to escape during this phase. They carried their valuables, they grabbed their children, and they ran. Some made it. Some did not. For those who stayed, whether because they were too slow, too confident, or simply believed the worst had passed, the eruption had a second act. And this is where the story takes a turn that science only began to fully understand in the late 20th and early 21st centuries. Beginning in the late evening and early morning of the second day, Vesuvius shifted into a new mode. The eruption column became unstable and began to collapse. When a column of superheated volcanic material collapses, it does not simply fall to the ground. It generates what volcanologists call pyroclastic density currents, avalanches of gas, ash, and rock that can reach temperatures between 200 and 500 degrees Celsius and travel at speeds of up to 300 kilometers per hour. These currents did not spare Pompeii. For generations, it was assumed that the victims of Pompeii died primarily from asphyxiation, that they breathed in toxic ash and gases and suffocated. And the image of people crouched in shelters, covering their faces with cloth, seemed to support this theory. But a series of groundbreaking studies, beginning with a landmark 2010 paper published in the journal PLOS ONE, challenged this assumption with hard physical evidence. The studies, led by Pier Paolo Petrone, a paleobiologist at the Federico Sette University Hospital in Naples, focused on the victims of Herculaneum, a coastal town approximately 11 kilometers from Pompeii, also destroyed by the eruption. In the boat chambers along Herculaneum's ancient waterfront, researchers found the skeletal remains of hundreds of people who had sought refuge from the eruption. Analysis of those remains showed something deeply disturbing. The heat they had been exposed to was not the gradual heat of a smoky fire. It was a virtually instantaneous thermal shock of extraordinary intensity. The researchers found evidence that many victims' body fluids had vaporized almost instantly. In some cases, the heat had been sufficient to cause the glassy vitrification of soft brain tissue. A man found in Herculaneum had his brain literally turned to glass by the heat. The temperature required for this process is extreme. The vitrification of brain tissue requires exposure to temperatures of around 500 degrees Celsius, sustained briefly. This is not a death by suffocation. This is instantaneous thermal annihilation. Back in Pompeii, the picture was equally grim. Studies analyzing the deposits and victim locations established that the fourth pyroclastic surge, the first of the powerful surges to actually reach and overtop Pompeii's walls, was responsible for the deaths of the majority of the city's remaining population. Numerical simulations and field studies determined that this surge exposed people in Pompeii to temperatures of at least 250 degrees Celsius, even at a distance of 10 kilometers from the volcanic vent. At such temperatures, death would have come in a fraction of a second, not the slow agony that previous generations had imagined. The bodies found frozen in agonized poses at Pompeii were not captured in their final moments of suffering. They were captured in something known as a cadaveric spasm, an involuntary muscular contraction caused by extreme heat shock that affects corpses, not living people. By the time their bodies assumed those haunting positions, the people of Pompeii were already gone. Of the approximately 1,044 victims whose remains had been recovered and analyzed in detail, about 38% were found in ashfall deposits, primarily within collapsed buildings, killed by structural failure during the pumice phase. The remaining 62% were found in the pyroclastic surge deposits. They were killed not by slow suffocation, but by a wave of superheated gas moving at catastrophic speed, even as science was reshaping our understanding of how people died in Pompeii. In a 2024 study published in the journal Frontiers in Earth Science, introduced yet another layer of complexity that had been overlooked for nearly 2 millennia: earthquakes. Pliny the Younger had mentioned earthquakes in his letters. Ancient writers had noted that the ground shook during the eruption. Scholars had always speculated that seismic activity might have accompanied the volcanic event. But speculation is not evidence. And for nearly 2,000 years, no concrete physical proof had been produced to demonstrate that earthquakes had played a meaningful role in the city's destruction or in the deaths of its inhabitants. The 2024 study, led by Dr. Domenico Speris, a volcanologist at the National Institute of Geophysics and Volcanology's Vesuvian Observatory, changed that. The research team, while working in collaboration with the Pompeii Archaeological Park, examined 2 newly discovered male skeletons found during excavations. Both men were approximately 50 years of age. Their positioning and the pattern of their injuries were telling. One man, designated Individual 1 in the study, appeared to have been suddenly crushed by the collapse of a large wall fragment. The trauma to his skeleton was consistent with a sudden, violent, compressive force, not with the gradual crushing of accumulated ash or the thermal effects of a pyroclastic surge. The researchers performed a detailed analysis of the structural damage visible throughout the excavated site and compared it against what would be expected from purely volcanic effects or ash loading, surge damage, and pressure waves, versus what might result from ground motion. The pattern of building collapse and victim positioning suggested that at least some of the destruction was seismic in nature, occurring during a brief period when the eruption had temporarily paused and survivors may have believed the worst was over. This pause, and what followed it, appears to have been fatal for a specific group of Pompeians. Those who had survived the initial pumice fall by sheltering in buildings may have believed, when the eruption briefly quieted, that safety was possible. It was during this apparent lull that earthquakes struck, collapsing buildings that were already structurally compromised by hours of pumice accumulation and the weight of ash on their roofs. People who might have survived the volcano were killed instead by the ground itself. Dr. Speris described the challenge of identifying this dual cause of death as being like a jigsaw puzzle in which all the pieces must fit together to unravel the complete picture. For the first time, that picture included confirmed seismic activity as an additional and independently lethal cause of destruction. What this means is that Pompeii was not destroyed by a single event. It was destroyed by a sequence of overlapping catastrophes: ashfall, structural collapse, pyroclastic surges of lethal temperature, and earthquakes, all interacting in ways that influenced the choices and the fates of 20,000 people over the course of roughly 48 hours. Perhaps the most intimate of all the mysteries surrounding Pompeii has always been the question of who its victims actually were. For more than a century and a half, the answer seemed obvious. You could see them. They were there in their glass cases and in the open display areas of the park, frozen in their final moments. A mother cradling her child, two sisters embracing, a family huddled together under a staircase. The emotional power of these images was overwhelming. They told a story of human connection in the face of death, of parents protecting children, of families refusing to be separated even as the world ended around them. In 1863, the archaeologist Giuseppe Fiorelli developed a method to make plaster casts of the victims whose bodies had long since decomposed within the hardened ash. By pouring liquid plaster into the voids left by the decayed soft tissue, Fiorelli was able to reconstruct the shapes of the victims with extraordinary fidelity. Over time, 104 such casts were produced. They became among the most recognizable and emotionally affecting artifacts in the history of archaeology. But something was already wrong with how those casts had been made, and nobody knew it for over a century. In 2015, during a major restoration project aimed at preserving the 86 most significant of Fiorelli's original casts, researchers subjected 26 of them to CT scans and X-ray analysis. The results were startling. None of the casts contained complete skeletons. More significantly, the analysis revealed that the casts had been considerably manipulated by archaeologists and restorers in the decades following their original creation. Features had been enhanced. Body shapes had been altered. Stabilizing rods had been inserted. The casts that the world had been looking at for over a century were not pure records of the victims as they had died. They were in part restorations, shaped by the assumptions and aesthetic choices of the people who worked on them. This discovery set the stage for a far more consequential investigation. In 2024, a landmark study published in the journal Current Biology, involving researchers from Harvard Medical School, the Max Planck Institute for Evolutionary Anthropology, the University of Florence, and the Pompeii Archaeological Park, reported the results of the first successful ancient DNA analysis performed on bone fragments extracted from the plaster casts themselves. The team analyzed 14 casts in total, successfully extracting usable DNA from 5 of them. The bone fragments were heavily fragmented and incredibly fragile, fused to the plaster in ways that made extraction technically demanding. But the results that emerged from the laboratory were worth every difficulty. Every single narrative that the cast had been thought to tell was wrong. The cast from the House of the Golden Bracelet, named for the adult figure wearing a gold bracelet who appeared to be holding a child on their hip and who had been identified for generations as the child's mother, was genetically an adult male. The bracelet was not a marker of femininity. It was simply jewelry worn by a man. And the child was not his. The two individuals were genetically unrelated. In the House of the Cryptoporticus, another pair of figures who had long been interpreted as two sisters dying in each other's arms included at least one genetic male. They were not sisters. Whether they were friends, strangers who found comfort in proximity, or something else entirely, science could not determine. But the story of two women embracing in their final moments was a story that had been written onto the evidence, not extracted from it. The DNA analysis also produced remarkable findings about the genetic diversity of Pompeii's population. All of the individuals studied showed ancestry that derived substantially from the Eastern Mediterranean, a reflection of the cosmopolitan, interconnected nature of the Roman Empire and its trade networks. 3 of the 4 individuals found in the House of the Golden Bracelet had ancestral roots in North Africa or the Eastern Mediterranean. Professor David Caramelli, an anthropologist at the University of Florence and a co-author of the study, summarized the implications with precision. The findings challenge assumptions about the association of jewelry with femininity and the interpretation of physical proximity as evidence of familial relationships. Professor David Rice of Harvard Medical School added another dimension. These findings challenge traditional gender and familial assumptions. The scientific data we provide do not always align with common assumptions. What the DNA study revealed is not just a set of corrections to individual stories. It reveals something more fundamental. The narratives we have told about Pompeii's victims were, in large part, projections. We looked at frozen bodies and saw what we expected to see: mothers and children, sisters and families. We assigned roles based on proximity and ornamentation, on assumptions about who wears jewelry and who comforts whom. The science stripped those projections away and replaced them with something harder and more honest: the truth that the people of Pompeii were individuals whose stories we can now only partially recover, and that some of what we thought we knew was always, at its core, something we had invented. There's one more piece of the Pompeii story that science has recently been forced to confront, a piece that fundamentally changes the way we think about the city's end. Pompeii did not die on the day Vesuvius erupted, or rather, it did not die completely, immediately, or permanently. For as long as scholars have studied the ruins, the assumption was clean and absolute. The eruption of 79 AD brought total and final destruction. The city was sealed under ash, and then it was gone. Its 20,000 inhabitants either escaped or perished. Those who survived never returned. New excavations at Pompeii have been challenging this picture. In 2025, the director of the Pompeii Archaeological Park, Gabriel Zuchtriegel, announced findings that confirmed what some researchers had long suspected but never been able to prove. People came back. In the months and possibly years following the eruption, individuals returned to the ruins of Pompeii. And some may have been survivors of the disaster itself, people who had escaped but had nowhere else to go, unable to afford resettlement elsewhere. Others appear to have been newcomers, drawn to the site by the opportunity it offered: empty structures, abandoned valuables, a place to build a life. The traces they left, the faint imprints of post-eruption habitation in the ash layers, had been noted by earlier archaeologists. But in the rush to excavate the more spectacular Roman-era artifacts, those traces had been brushed aside and in many cases discarded without documentation. What this means is that the boundary between Pompeii before the eruption and Pompeii after is less clean than we imagined. There was life in the ruins. The ash-covered streets were walked again. The sealed city was not quite as sealed as the mythology required. This discovery adds yet another dimension to the complexity of Pompeii's story. The city's destruction was not a single, instantaneous, total event. It was a catastrophe that unfolded in phases over 2 days, that killed people through multiple overlapping mechanisms, that froze a specific moment in time, but also left room for a messy, human aftermath that science is only now beginning to illuminate. After 1,947 years, what has science actually solved about the destruction of Pompeii? It has established, with physical evidence for the first time, that the primary cause of death for the majority of Pompeii's remaining inhabitants was not suffocation by ash, but instantaneous thermal shock from pyroclastic surges traveling at devastating speed. The contorted bodies in the ruins are not frozen in agony. They are frozen in the involuntary spasm of muscles responding to extreme heat, long after consciousness and life had ended. It is confirmed with skeletal and genetic evidence that earthquakes accompanying the eruption played an independent and lethal role in the destruction, killing people who might otherwise have survived the volcanic phase of the disaster by collapsing already weakened buildings during a brief and cruelly misleading pause in the eruption. It has demonstrated, through ancient DNA analysis, that our understanding of who the victims were, their gender, their relationships, their origins, was systematically distorted by assumptions and by deliberate modifications made to the plaster casts in the decades following their creation. The emotional narratives we have attached to Pompeii's victims were largely invented, however well-intentioned. It has reopened rather than closed the question of exactly when the eruption occurred, showing that certainty in historical dating is often built on far more fragile foundations than we like to admit. And it has revealed that the destruction itself was followed by human life, that the story of Pompeii does not end with the ash, but continues in the faint, overlooked traces left by the people who came back to walk among the ruins. What science has given us, after nearly 2,000 years, is not a simpler story of Pompeii. It is a more honest one. It is a story that respects the full complexity of what happened, the multiple interacting forces of destruction, the individual human beings who are not archetypes, but real people with genetic histories and personal choices and unknowable inner lives, the long, difficult aftermath that followed the disaster, and the irreducible uncertainty that remains at the edges of even our best understanding. Mount Vesuvius still stands. It is still classified as an active volcano. The millions of people who live in its shadow today, in Naples, in Herculaneum, in the towns that have grown up around the ancient sites, live with a risk that is, in geological terms, very real. Scientists who study the volcano apply everything learned from the analysis of the 79 AD eruption to the challenge of understanding what Vesuvius might do next. In this sense, the mysteries of Pompeii are not merely historical curiosities. They are urgent scientific questions. And the answers that researchers have painstakingly assembled from bone fragments and pyroclastic deposits and ancient DNA and charcoal graffiti and the fragile, centuries-old letters of a Roman teenager who watched a mountain destroy a world, those answers matter for the living as much as they illuminate the dead. The city at the foot of the volcano has been waiting nearly 2,000 years for the truth. Science, patient and persistent, is finally beginning to deliver it,